couple of weeks or couple of days. So that is your ripple effect. What is this COVID-19 scenario? What is this COVID-19 scenario? Ripple effect. Yeah. You can start. It's already okay. Okay, no worries. Yeah. Okay. The technician is not there, so that he is monitoring from that room. Okay. Good morning, everybody. Let me see. Good morning, everybody. Yes. Welcome to the last day of our GAN course, Next Gen Supply Chains, Harnessing IoT, Digital Twins, and AI-driven Simulation. I hope you have been enjoying this session. And today is the last session of our GAN course. And in today's session, we are going to talk about the future trends in supply chain digitalization. Yesterday, we looked at the blockchain, one of the important technologies in Industry 4.0 or Industry 5.0. We looked at how the blocks are made in that blockchain. Why do we call it as blockchain? What are some of the important terminologies in that blockchain technology? And we played very interesting game as well. I hope you had enjoyed that game, blockchain game. Okay, so in today's session, we are going to talk about the future trends in this supply chain digitalization, where the world is heading in this supply chain digitalization that we are going to discuss. So these are the session objectives. At the end of the session, participants will be able to understand some of the emerging technologies. So we already discussed couple of technologies in our previous sessions. AI, artificial intelligence, blockchain, IoT. Okay, but I think I need to turn on the volume. Can you hear me now? Okay. Volume. I don't know. Can you go and check with the Venkat whether he can hear properly recording? I think there is something going on. That's why the technician went to look at that one. Good. Okay. So session objectives. Yes. At the end of session, you will be able to understand some of the emerging technologies in supply chain digitalization. We are going to identify the future challenges and opportunities in this digital supply chain, and we are also going to look at what are the barriers and limitations, because at one end we are talking benefits, all the all benefits and other opportunities we get from this Industry 4.0 or Industry 5.0 technologies, but at the same time we need to look at the social barriers as well. What the workers, the employees, or the other public, they will think about, or they will face any will they face any barriers, that we are going to talk about. So okay, so we talked about the Industry 4.0 in our initial sessions. So do you know Industry 5.0 is already there? Does anybody know the difference between Industry 4.0, Industry 5.0? What is it? Yeah, go on. Integrating with? Yeah, okay. What else? Human machine interactions, human cognitive personalization. Yeah. What else? Yes. So basically, you covered everything. So I will tell you the important component of the Industry 5.0. So Industry 5.0 places the well-being of the workers at the center of the manufacturing process. Because if you look at the Industry 4.0 technologies, all these blockchain, IoT, artificial intelligence, cloud computing, CPS, and big data, we are talking about how we use these technologies to improve our operations, to enhance the business performance. But one of the important thing we need to look into this advanced digital technology is the workers, the employees. Suppose all these the robotics, all these advanced automations, if they take the jobs of the employees, what would happen? How they can survive? So in the Industry 5.0 center, the focus is main on the workers, those who are working in the factories, in the manufacturing processes. By making production respect the boundaries of our planet, every company wants to increase their profit in, that's why they are using these technologies. Okay, so but you cannot do this by by making huge amount of emissions or different kinds of pollutions, or by at the cost of losing the jobs. So that's why when we focus on improving the business processes, your performance, supply chain performance, we need to do this considering the boundaries of our the planet, how much we should use. Basically, sustainable means we have three dimensions: economic, environmental, and societal dimensions. So at one end we are trying to improve this performance, we are talking about growth, but what about the environment? We are facing this climate change, flooding, tsunamis, all these unexpected events, and this is very common nowadays. If you look at the 10 years before, 20 years before, we had not this kind of problems, but now because of this climate change, pollutions, we are facing these unexpected events regularly, and this is affecting everybody. As a human being, it is affecting our health, it is affecting the society, everybody. So whatever we are doing with this advanced digital technology, we need to focus on the environmental impact of our operations. Okay, so suppose this blockchain, yesterday I talked about blockchain. For that technology, we need huge amount of the computing power. Huge amount of computing power means cost is there, the emission is there. So then if you are talking only about the cost perspective, only talking about the efficiency, what about the environmental impact? What about the workers, those who are working in those factories? So that's those things we need to consider. And the harmonious symbiosis between humans and machines, collaboration between humans and machines, robots, to achieve the societal goals beyond jobs and economic growth. So when you say triple bottom line approach and we talk about the societal, we normally think about the jobs, how we could create the number of opportunities, jobs, and the economic growth of those things. But in addition to that, there are some additional societal goals we need to think about. As I said, public health, how these technologies are affecting the public health, and some other societal goals. And further achieve sustainable development goal of super smart society. When you use Industry 4.0 technologies in your factory, in your warehouse, we call it as smart factory. Yesterday, not yesterday, before yesterday, I have shown you one smart home, where we have got all the smart devices, your smart AC, smart bulbs, smart curtain, and all those things. Okay, so we are focusing on this super smart society with all these digital technologies, and then along with sustainable development goal as well. and ecological values, which will become a robust and resilient provider of prosperity in an industrial community of shared future. Have you heard this sustainable development goals term? What are the sustainable development goals? 17 goals are there. Who defined those 17 goals? United Nations. Can you tell me a couple of goals? Mhm. Yeah, no poverty, zero hunger, quality education, then a life below the water, life on land. So there are 17 goals are there. And what is the purpose of these sustainable development goals? Okay, United Nations developed these goals. What else? So all the United Nations member, they are working towards the achievement of these goals by 2030. Okay, but now because of this COVID and some unexpected events like Russia-Ukraine war, geopolitical crisis, many countries, they are struggling to achieve those sustainable development goals by 2030. And that's why I give one example as well in last session as well. Like in the UK, initially UK decided to stop the sale of petrol and diesel cars by 2030, so that they can achieve their net zero target and to achieve these sustainable development goals. And then companies, all the automotive companies, they started working towards that hybrid electric vehicles. And suddenly after COVID-19, the government thought that it is very difficult now to achieve this target by 2030, and they decided to move that target by 5 years, 2035. Okay, so this happened because of COVID-19. Because COVID-19, we know that what happened, your GDP went down. Every country, they experienced the significant losses. Okay, and then after COVID-19, nobody was talking about the environmental and societal impact. Their main focus was on economy, how to boost your economy. Then they thought that after some time we will talk about this the environmental impact and then your societal impact. But at the moment, we need to improve our economy. So that's the basically the sustainable development goals. And every country, they are trying to work towards the achievement of these sustainable development goals. Then robust and resilient provider of prosperity. So this is again very important component of the industry 5.0. So in industry 4.0, we talked about all these advanced technologies, how this could help to improve our businesses of supply chain, all those things. But we didn't talk about the resilience or robustness of your supply chain. Do you think that these technologies, how you could help to improve your robustness or resilience of your supply chain? That part was missing there. Then again, well-being of the workers, human-centric. So it enables, Industry 5.0, it enables human and machine to work hand in hand. Human and machine means your robots. Earlier, we need to code we need to do the coding to to run your robots to do the work. But nowadays, there is some advanced technology came. It is called cobot. Have you heard this term, cobot? It's collaborative robots. So robots, they collaborate with each other. They sense the human sometimes decision making process, and they take the decision based on that one. So this cobots means collaborative robots. So the robots, like as I said, IoT devices, what they do, they interact with each other and they make the decisions based on the whatever the command or input data you have given. So cobots means collaborative robots, are not programmable machines, but they can sense and understand the human presence. Okay, so we don't need to code anything, or we don't need to ask anything for that collaborative robots. They sense and understand our presence, and according to our data, input data, according to our requirement, they take the decisions. Industry 5.0 added human-centric, sustainable and resilient concepts to the industrial revolution. So this is the fifth industrial revolution. So far, first industrial revolution, second, third, fourth. In the fifth industrial revolution, these three important components are there. What are those three important components? Human-centric. Human-centric means the focus on the well-being of the workers. Suppose because of this advanced technology, if workers, they are losing the job and they are not able to improve their skills, what is the use of this technology? So we need to do something so that they will improve their skills. They get some advanced knowledges of these technologies, all those things, and it will be beneficial for the society. So human centric means it promotes the talents, diversity and empowerment of the workers. So human centric approach. Then resilient means when you use these technologies, we should also focus on the agility and resilience nature of the supply chain with the flexible and adaptable technologies. Suppose you are using these technologies and some unexpected event occurs in your supply chain, and if your supply chain is not flexible, what is the use of that your technology? So when you use this technology, whatever blockchain, IoT, advanced technology, your supply chain should be agile and flexible considering these advanced technologies. Okay, so that suppose if your normal supply chain is robust and resilient, and when you convert into this digital supply chain, or when you use this advanced technology, we also need to make sure that when unexpected event occurs in your supply chain, you can make the changes in your supply chain very fast, and your supply chain should be flexible, resilient. And what is the sustainable? Leads action on sustainability and respects the planetary boundaries. Planetary boundaries means we are facing all these problems now. Soil degradation, deforestation, this temperature is increasing, tsunamis, flooding, all not like India. Everybody, if you look at the developed countries as well, the frequent fires in US, now Los Angeles, the wildfire, it cost them around 150 to 160 billion USD. Similarly in UK as well, if you see, we are regularly facing the flooding problems. Why? Because of the climate change. Okay, so when we are using this advanced technology, we need to focus on this human centric approach, resilient, and then at the same time we need to make sure that we are not harming our environment. Okay, so sustainable means it should be economically viable, your the supply chain, but at the same time it should not be making any severe harms, or it should not be negatively affecting your environment. So that's it leads action on sustainability and respects the planetary boundaries of your basically supply chain. So that's the three important. So please keep this in mind whenever you hear this term Industry 5.0. Human centric promotes the talent, diversity, empowerment, because the workers, they need to improve their skills to accommodate this advanced technology. Resilience means all this technology, they should be flexible enough to deal with any unexpected events. And the sustainable means we should not harm our environment. We need to look after the societal problems, societal goals. These are some of the Industry 5.0 technologies. Some of these technologies you may think that some of the technologies they are overlapping with the Industry 4.0, such as big data, cloud computing, fog edge. This is basically the Industry 5.0 technology. Digital twins, then extended reality, Internet of Things, robots and cobots. Cobots means collaborative robots. 5G, 6G technology. Now the researchers they have already started working on the 7G technologies as well. Additive manufacturing, then smart additive manufacturing with the advanced technologies. So these are some of the technologies of Industry 5.0, and we discussed couple of technologies already. Digital twins, we talked about cloud, fog, edge computing. What is the difference between these three? Cloud, fog and edge computing? What is it? And what is the fog? In between, yes. Then blockchain, we talked about blockchain. Big data, what are the 5 V's in big data? What are the 5 V's of big data? Velocity. What is it? Variety. So there are 5 V's of big data. Unmanned and autonomous vehicles. Then we talked about the driverless cars as well. 5G technologies, artificial intelligence. We are going to talk about the artificial intelligence in today's session. So what are the difference then between Industry 4.0 and Industry 5.0? Any idea? Yes, that's correct. 4.0, we mostly focused on all those advanced digital technologies, but we can consider the human-centric approach, sustainability, resilience, those things. So here in Industry 4.0, focus was on connecting your whole supply chain, from supplier end to the customer end. How can you connect that one? With the advanced technology, IoT devices, blockchain, and then artificial intelligence, big data. So the focus was on, to improve the visibility, make your supply chain digital, so that, all the members, they get the timely and accurate information from the other members of the supply chain, and they can then, take the decisions accordingly. So focus was on connectivity. So what about Industry 5.0? Delivery of personalized experiences. Delivery of personalized experiences. So basically, so customization, we can say that, mass personalization. So whatever the customer's requirement are there, individual requirements are there, we could satisfy those requirements basically with the help of this Industry 5.0. Delivery of personalized experience. Then in Industry 4.0, we talked about our main focus was on mass customization. So in Industry 4.0, second revolution, in the technology revolution, our focus was on mass production. What is mass production? What is mass production? What is mass production? And when it was started? Production in huge number of quantities, mass production. Okay. Then what is mass customization? You are customizing the product you are at use. I don't know. So here in Industry 4.0, our focus was on mass customization. Industry 5.0, mass personalization. So we want to satisfy the individual requirements of the customers. That is our mass personalization and hyper customization. Industry 4.0, smart supply chain. We called it as smart factory, smart warehouse, smart distribution center, or your smart factory with where we use the advanced technologies to manage our operations. Smart supply chain. Here, responsive and distributed supply chain. Our focus was on responsive, sustainable supply chain. Responsive, sustainable means if something unexpected happen, we can very easily manage our the operations with the help of this advanced technology. It means your supply chain is flexible enough to manage those unexpected events. And then distributed supply chain again, and the sustainable supply chain. We should not harm our environment while taking the benefits of these advanced technologies. Industry 4.0, smart products, smart AC, your smart windows, smart bulbs. That was the focus on Industry 4.0. And here, interactive products, experience activated, augmented reality. So where you want to see the the experience, or you want to improve your immersive experience. So those kind of interactive products are there, and you can use those products for the supply chain in other operations. Remote workforce. Industry 4.0, focus on the remote workforce means IoT devices we can manage from anywhere, all those things, and you can get the information here. On-site workforce. So here in Industry 5.0, our one of the important component is human-centric. Okay. So here we want to make sure that the workers, employees, those who are working in those factories, warehouses, they are also getting some benefits because of this Industry 5.0. That's why we looked at the on-site workforce in this Industry 5.0. 6G. So currently we are using the 5G, but now, as I said, 6G, it is already coming up, and then scholars, they are working towards the 7G. evolution of networks from 1G to 6G, enabling AI, IoT, and AR advancements. So when you integrate the artificial intelligence, IoT, augmented reality, so those kind of the benefits we get from the 6G, and this technology 6G is very needed, because when you want to transfer the information, if your connectivity is not good, then what's the use of that your network or the information? That's why integration with blockchain cyber twin for sustainable energy management. So 6G, we are talking about 6G, 7G, but what is the effect of that on your the sustainable performance energy? So here we can integrate with the blockchain cyber twin for sustainable energy management. Frequency selective surfaces, enhancing the signal quality, and it helps to reduce the interference as well. Semantic and goal-oriented 6G, efficient communication with the semantic learning. So there are some other technologies you can see. 7G vision. I think something is happening. Okay. वहाँ पे ठीक था ना सब रिकॉर्डिंग? ठीक है. 7G vision, ubiquitous wireless connectivity, AI-driven automation, and space-based communication. So this is the focus of 7G. Then future technologies. Already we are talking about Internet of Things, Internet of everything. But already because of this advancement in the connectivity technologies, there are some the research going on into the Internet of Nano Things, bio nano things, and quantum communication shaping 6G plus. So these are the this is again one of the important technology in industry 5.0. Collaborative robots, it means cobots. And in this collaborative robots, the collaborative robots, they collaborate with each other without any the human the feedback, or without any human interactions basically. So what is the manufacturing impact of these cobots? Enhancing productivity, ergonomics, and task scheduling. Okay, so it will enhance your productivity of your supply chain, productivity of your manufacturing factory or the distribution center. Ergonomics wise, it is also very beneficial, because if you are doing the the regular task with the help of your normal robots as a human being, that will be problematic. So ergonomics wise is also good. Task scheduling, they will collaborate with each other robots, and they manage the task scheduling. Industrial application, adoption by major manufacturer, future trends in cobot development. So some companies, they have already started using these collaborative robots to improve their supply chain operations. Human cobot interactions, advanced technology, how we can as a human being we can collaborate with this the robots. Role in industry 4.0 and 5.0, workplace design consideration, operator involvement. So when workers, employees, they are working in the factory, how they can work in the or how they can collaborate with these collaborating robots, so that they can sense, understand what we want to do or what we wanted to say. So that's the human cobot interaction or human machine interaction. What is the difference between collaborative robots and traditional? So here, direct human collaboration, virtual surfaces for motion control, ergonomic benefits. So it will automatically, collaborative robots automatically sense what's happening in that factory, what's happening in their distribution center, and accordingly they will manage the operations. So you don't need to do so many things in this collaborative robot environment. Advanced application, tool guidance in surgery. You might be aware of the some robots, they do the surgery as well. So during that surgery, suppose two robots are there collaborative, they will help each other to to manage that surgery. Haptic feedback for CAD models or safety focused control modes. Autonomous service cobots, navigating office spaces, episodic localization, AI driven task scheduling. So these are some of the application of your autonomous service robots or the collaborative robots. Circular economy, have you heard this term? This is also one of the important technologies in industry 5.0, or you can say in the advanced digital technologies. What is this? policy. Okay. Anyone else? What is circular economy? What is linear economy? How does normally we make this product? We source it, raw material component from the supplier. We make it, we use it, and what else? Recycle. Do you do this in linear economy? After use, we dispose it, we throw it. That is your linear economy. We make it, we use it. But initially, we source the material to make it, we make it, use it, and after its useful life, we throw it in the dispose. So, what's the problem with this model, linear economy? Sorry? Waste. Okay. What else? Yeah, so environmental means you are unnecessary, throwing that product into the waste, and then that will affect the environment as well, pollution, air pollution, water pollution. And again, another waste example, when you buy a cup for coffee, drink or tea. So when you use it, after it's used, what do? You use it to keep your pen as a pen stand or something like that. That's the example of circular economy. So you are using that product after its useful life as well to gain some additional benefits or to capture some value from that product. So that's your circular economy model. So the circular economy is a system where materials never become waste and nature is regenerated. So we try to use use the material as much as possible before it goes into the waste. Okay, you could find some application or some uses of that products before it goes. That's why these refurbished products are there, remanufacturing, recycling. These are some of the ways we can find out, or we can take the useful value from those products. So circular economy is a economy, or is a model where material never become waste and nature is regenerated. In a circular economy, products and materials are kept in a circulation. We try to make, use, and dispose. So this is your linear model. But in circular economy, make, use, and rather than dispose, again reuse, again refurbish it, remanufacturing it, or again go back to the recycling. What is the recycling? Do you know? There's a difference between reuse, remanufacturing, recycling. Recycling is the last stage in that your circular economy model. So means whatever the product is there, we use that product as a raw material to make a new product. Reuse means we are using that the coffee cup, as I said. We are directly using it. We are not making any changes into that one. Reusing. Remanufacturing means we are making some changes in that one, refurbished products. So that's your remanufacturing. So here products and materials are kept in circulation through processes like maintenance, reuse, refurbishment, remanufacturer, recycling, and composting. So these are some of the ways through which we try to circulate the material products in your economy rather than throwing it away in the bin. Okay. Circular economy tackles climate change. Why? We are not generating unnecessary waste. It is good. Suppose take the example of electronics waste. Huge amount of electronic waste is generated across the world. Okay, suppose you reuse those laptop, mobile phones. It will save the cost. It will save the resources. It will save the environmental impact as well. So that's the purpose of the circular economy. It tackles the climate change and other global challenges like biodiversity loss, waste, and pollution. Because when you make the new product, sometimes you need the virgin material, to make that product. Okay, when you use this circular economy, you basically use the material of the existing products to make that product. So we don't need the additional extra virgin material to make those products. By decoupling economic activity from the consumption of finite resources. The circular economy is based on the three principles. What are those three principles? Eliminate the waste and pollution in your supply chain or in your operations. Try to eliminate the waste. How you can make it? By using reuse. When you reuse, you are reducing the waste. You are reducing the pollution. How you are reducing the pollution? You are unnecessarily stopping or making the new products. Why? Because you are using it. When you make the new products, you create the pollution, you affect the environment. So through that way, you can avoid the waste and pollution. circulate products and materials at their highest value. Not only the reuse. Suppose after that useful life of that product, your first job is to reuse that product. After reuse, suppose you think that okay, that's done now, so you go to the remanufacturing stage where you make some changes in that product and then again reuse. Again, suppose after remanufacturing as well, suppose you use that product, again directly throw it. Go to the recycling stage where you use that product as a raw material to make the new products. So that's your recycling nature. Circulate products as much as possible at the highest level, in your supply chain model. Regenerate nature rather than destroying your biodiversity or nature. Regenerate nature through this circular model. This is underpinned by a transition to a renewable energy and materials. The circular economy is a resilient system that is good for business, people, and the environment. So nowadays, everybody is talking about this circular economy, and they are trying to reduce their waste, pollution, and trying to circulate those products in their supply chain. So this is your linear and versus circular economy. So in linear supply chain, we source the material from the earth, from your supply chain. You make the products in your factories, then you make the product in factories, then you distribute it, then we use those products and we dispose it. So what is the problem here? We are creating unnecessary waste, pollution, all those things. We are not trying to focus on reusing, remanufacturing, so that how we can get the maximum benefits, maximum value from that product. If you look at the circular economy, you take the product from the earth, extract the raw material, the components, remake. Again, you are making it. Remake means you are remanufacturing it, because suppose after the the useful life, when the customers they get the products back to the manufacturer, they use that for the remanufacturing purpose. Remake, distribute, use, reuse, or repair. As I said, when the useful life of that product is done, then you can use it for the another purposes, reuse. Sometimes we do the normal repair and then we can still use that product. So that's your repair. Selectively dispose. Again, if you want to dispose something, there are some ways available to safely dispose those products. And recycle means the last stage in your circular economy. That product goes into the as a raw material or component to make the products. So that's your basically the circular economy model. Can you give me another example from your real life? Any example? Circular economy. I gave the example of that coffee cup, coffee mug. By yeah, yes, that's correct. What else? Plastic bottles. How do you do? What do you do there? They are recycling. Yeah, we collect them and we do the recycling. What else? Notebook. Yeah. After its useful life, what do you do? Do you do the remake, remanufacturing, recycling, or another example is cloths. When we use these cloths, after we think that this is not good for us, we donate it to the charity. We donate it to the charity, or sometimes in our villages they use it to make some rope or something else. Okay, for other purposes they use those products. So that's the example of your linear versus circular economy. For your projects, if you are working on some your master project or UG project, again this is very interesting topic. If you are engaging with any companies or anything, you can discuss how they are following the circular economy model. You can do the mathematical modeling here, so that electronics products are another example. Go and check there. There is no problem. There is no problem with it. Okay, we'll try. So another example is electronics companies. Do you know? They collect the used products after the from the customers. that one. They can use some IC from that chip, whatever the products from the components from that used product, and then they reuse again to make the new products or refurbish mobile phones. Those are the some of the examples. Do you know this guy? Any idea? We are all talking about artificial intelligence. So do you know this guy? So he was a Herbert Simons, and in 1965 his quote was very famous: "Machines will be capable of doing any work or a man can do." So he significantly contributed to the decision-making theory. So his main contribution was in the economic theories. He integrated the multiple scientific disciplines into economic theories. He challenged the idea of complete rationality in decision making. Do you know what is complete rationality and bounded rationality? Introduced to the concept of bounded rationality, recognizing that the individuals and businesses do not always act purely rational. What is this complete rationality and bounded rationality? Unlimited cognitive, your cognitive ability, and basically taking the decisions. Complete rationality means we think that we know everything about that situation, we have the complete information, and we have got unlimited cognitive ability before making any decision. But do you really do that in real life? Suppose if you want to buy any cell phone, do you think that you do all the study of all the models, all the companies available which are selling the mobile phones? So in real life, complete rationality doesn't work. Okay. So basically, suppose I want to buy a phone, what I do? I have something in my mind. I want to go with the Samsung, Nokia, Apple, and so on. I go to the the website, I check it, and I buy it. I don't do the full research, complete. I don't know the complete information about that situation. Okay. So in bounded rationality, we have limited cognitive ability and we have imperfect information. We don't have the perfect information or the full information. So in real life, everybody they basically follows the bounded rationality. If you take the as a human being, company, everything, so they follow the bounded rationality. So he described the companies as adaptive systems with physical, personal, and social components, and he provided a new perspective on decision making in modern society with the help of this bounded rationality concept. And because of this, his contribution in bounded rationality and economic theories, he got the Nobel Prize in 1978. Okay? So very interesting stuff about the artificial intelligence and the bounded rationality. Then what is the evolution growth of artificial intelligence? Because artificial intelligence is a very important technology for our industry 4.0 or industry 5.0. So who coined this term? Basically, origin and early definition, coined by John McCarthy in 1955 to explore the machine intelligence. So then after 1955, there are some developments as well in this artificial intelligence area. So key developments: Russell and Norvig, 2009. Don't know what's happening. Okay, so John McCarthy in 1955 coined this artificial intelligence or machine intelligence term. Then after that in 2009, Russell and Norvig assessed on rationality and human-like thinking. So AI research evolved from low interest to rapid growth. So you can see some modern AI application like AI, IBM Watson. IBM Watson, medical diagnosis, Tesla fleet learning, self-improving autonomous vehicles, driverless cars. What are the factors driving AI growth? Improved computational power. You know, the computational power is significantly improved. That's why. Big data and IoT adoption, advancement in learning algorithms, massive investments by Google, IBM, and some top companies. So adoption of cutting edge technologies by supply chain companies in 2021. So this is a survey conducted uh, uh, for 174 respondents, supply chain professionals, and in this survey they asked which technologies they are using. So you can see in blue is in use today, and the dark black it shows the next 5 years. So cloud computing and storage, 40% of the companies they are using it, and then you can see the inventory and network optimization tools have the highest use in next 5 years. You can look at the predictive and descriptive analytics as well, and artificial intelligence technologies as well. So what are the classification of AI, guys? Do you know the classification of AIs? Thank you. Strong, weak AI. Okay. Anyone else? So here you can see the taxonomy of AI. So in AI we have got three kinds of basically categories. First one is the sensing and interacting classification or category. Here we have got three subcategories. Vision, in vision category we have image recognition, machine vision related algorithms, speech recognition, speech to text, text to speech, natural language processing, extraction, classification, translation, text, question answering. Okay, so these are the some of the classifications of natural language processing. Then you have got the machine learning, supervised, unsupervised, reinforced learning. I hope you know what is supervised, unsupervised. Decision making, we have got the simulation and optimization, simulation and modeling, optimization, nature inspired algorithms. What are the some nature inspired algorithms? Any idea? Uncolony, genetic algorithms, knowledge based, market based, or game theory based algorithms, decision theory based, planning and scheduling, and expert system like rule based, fuzzy based system, frame based, or hybrid. So these are the basically the classification of AIs. So we will see one by one. First one is the AI sensing and interacting. So one category is natural language processing. So it enables human like text understanding and generation. That's why we call it text extraction, classification, translation, generation, and so on. Use case, NLP enhances supply chain mapping from unstructured data. Then speech recognition, converts the spoken words to text and vice versa. Basically, some of the challenges in this speech recognition is accent, word similarity, sound quality. In some advanced, the smart homes, you can, or Alexa, Siri, these are the some of the examples of your speech recognition categories. Accents, word similarity, sound quality, these are some of the challenges. Then third category is computer vision and AI based image analysis. Image recognition identifies and detects objects in images, videos. Machine vision captures, processes, and interprets images. And again, use cases, autonomous vehicles. You can see in autonomous vehicles, they capture the objects and then they do the analysis. So that is your computer vision and AI-based image analysis. Learning from data. This is the category. Machine learning develops algorithms that learn from data to solve problems. So used extensively in time series forecasting. So there are three categories of machine learning. First one is supervised learning, trained on labeled data to predict the outputs. Examples, decision trees, linear regression, support vector machine, neural networks. Unsupervised identifies the patterns without label data. We don't need the label data there. So example, clustering techniques. What are the some other examples? Unsupervised learning. What? We'll see. Reinforced learning learns via trial and error, receiving feedback. There is a difference between unsupervised learning and reinforcement learning. What is that difference? Basically, reinforced learning, yeah, feedback, yeah. So in reinforcement learning, you get the feedback after the execution of that, the whatever the operation, and you improve based on that feedback. This is a trial and error method. In unsupervised learning, we don't do that. Example, reward-based optimization. Deep learning spans across all three ML categories, and it drives AI advancement in big data and automation. Decision making, we have got optimizations, solving the complex supply chain problems dynamically. We looked at the optimization. Expert system, AI driven knowledge based systems for decision making. Modeling and simulation, we learn about how to model the supply chain, how to do the simulation in any logistics tool. Planning and scheduling, optimizing the activity sequences and resource allocation. And these are some of the optimization methods, like nature inspired, game theory, market based, decision theory, knowledge based. So AI enhances the predictive maintenance because of these advanced technologies, fraud detection and system recovery. It improves the responsiveness and data driven decision making in supply chain management. So what is machine learning now? What is machine learning? By repetitive tasks. So machine learning is the science or art of programming computers or machines so that they can learn from the data. So that's your machine learning. Scientific definition, if you look at, a computer program is said to learn from experience E with respect to some task T and some performance measure P. Experience is E, task T and some performance measure P. If its performance on T as measured by P improve with the experience. So when you feed additional data, when that machines learns from the experience and it improves its performance. So that's your machine learning. What are the classification of machine learning? Supervised uses label data sets to train algorithms to classify data or predict the outcome. Unsupervised means, what is it? Discover the hidden patterns within the data without explicit labeling or human intervention. We don't need the label data in unsupervised. Semi-supervised exploits the data set in which some instances are labeled and others are not. Reinforcement learning, it learns from the trial and error method. The feedback is the main important thing. Supervised machine learning is associated with the development of algorithms that can learn by training data to solve problems using knowledge obtained from the previous problems. So supervised learning is about training a machine, training a computer with a known data set. We call it as training data set, training samples to predict an output. Supervised learning models, example, decision tree models, your linear regression and support vector machines. Regression normally we use for continuous and numerical data. Estimate the relationship between a dependent variable and at least one independent variable. Logistic regression, polynomial, SVR and so on. Classification, we use it for discrete and categorical data. Determine which category a set of observation belong to. Then logistic regression, example, K nearest neighborhood and SVM. Unsupervised, the machine will learn to recognize patterns without any trained data set or pre-labeled information. Unsupervised learning is widely used in clustering algorithms or clustering problems to identify the similarities and genetic algorithms. Example, clustering. What is the purpose of clustering? Groups the object together so that items in the same cluster are similar. K means clustering. What is dimensionality reduction and for what purpose do we use it? To reduce the computation. Suppose you have got the huge amount of data, okay, and it is very difficult to manage that data or to analyze data. So sometimes what we do, we try to reduce the size of that data, dimensionality. But when you reduce the size, you make sure that the important information is available or important parameters are available in the data set. That's called dimensionality reduction. One of the important method is PCA, principal component analysis. It transforms the data from high dimensional space to lower dimensional one, retaining meaningful properties. Principal component analysis, LDA, generalized discriminant analysis. Reinforcement, similar to unsupervised, but difference is that machines receive the feedback after completing the task. In other words, machine improves its performance by trial and error method. So that's your reinforcement learning. While supervised learning mainly deals with classification and regression problems, unsupervised and reinforcement they deal with the clustering and reward based problems. So these are the some of the algorithms normally we use for the supply chain or logistics management problems. Artificial neural network, multi-agent, genetic algorithm, data mining, swarm intelligence like particle swarm optimization, decision trees, association rule, robot programming, heuristics, k-means, and so on. You can refer this paper if you want the more information about this one. So tell me, then on this slide you can see the what are the general uses, advantage and disadvantages of each algorithm. Suppose decision tree, it is used, what is the general use? Discriminant models, multi-regression and classification. What are the advantage? Easy calculation, able to assess, strong interpretability, but disadvantage, easy to be overfitting. So when we use this model, we look at the overfitting, underfitting as well. Random forest. So what is the problem with the k-means, guys? Any idea? There is a problem with the k-means. K is not defined. Okay, what else? Major problem is that it is sensitive to the noise and outliers. Okay, so that's the major problem. Actual time given by cluster K is sensitive to the initial values, only used when cluster mean values have been defined. So K means we define the values, number of how many cluster you want. So that's the problem with the K means. Then you can see support vector machine, neural networks, logistic regression. Again, very interesting table. You can find the reference here, and then they have advantages, disadvantages of each method. How do you select the algorithm? You may be aware of this cheat, basically Skykit learn algorithm cheat sheet. Start, and first thing is to see the samples. How many samples are there? If your samples are greater than 50, go. If your samples are less than 50, get the more data. You need minimum 50 samples for doing this kind of analysis. If your samples are more than 50, then look at this question. Are you predicting the category? Yes. Do you have a label data? Go here. How much sample size is there? Less than 100K? Yes. Linear SVC, text data, naive base. If it is no, go to the HJD classifier kernel approximation. So this is basically classification. So then predicting a category, if data is not labeled, you are clustering. You go with the number of categories known, and then how many size is there, and again, so this is there. Regression, again, if you are not predicting the category, are you predicting the quantity? Yes, regression. If you are not predicting the quantity, what you are doing, just looking at the dimensionality reduction. This is the one. So again, you can see this example. The source is also given. What are the applications of AI in supply chain management? AI can offer shippers faster delivery times and increase reliability. You can get the expected time of arrival of your ship or expected time arrival of your delivery. You can use the predictions as well, more accurate predictions of arrival times. You can use the improve the delivery times as well. We can analyze the historical data by considering the factors such as weather patterns, busy or slow shipping seasons. We can use the AF2 for digital charting marketplaces, and then we can use for the routing as well. Routing. What do you do in the routing problem? Vehicle routing problem? What do you do in vehicle routing problem? Find the optimal route from one point to another point. So we use AI for that one. Arrival time forecasting, expected arrival time we can find out. Demand forecasting we can do. We can optimize the processes. We can optimize the traffic flow and location prediction, vehicle routing problem. And these are some of the key applications of human-centric manufacturing in Industry 5.0. So key technologies and application. Collaborative robots. This is the application. Key technology we are using cobot, sensor, machine, augmented reality application for training and maintenance. So ER headset, 3D modeling. So now all these are the available technologies. Wearable technology for worker safety and monitoring. So wearable nowadays in smart factory workers they wear this the advanced technology, smart glasses, safety vest, sensor, GPS tracking, machine learning. So that they can improve their processes operations. Predictive maintenance and quality control, IoT sensors, machine learning, and so on. Digital twinning, we application simulation software we use there. IoT sensor, machine learning. Resource optimization, we can use the Industry 5.0 technology, IoT sensors, machine learning. Circular design principle, circular means circular economy. Design for disassembly, materials innovation, then sustainable materials, green supply chain management, waste reduction and recycling, real-time production monitoring, we can use it, predictive maintenance, supply chain optimization. Society 5.0. So this is again advanced the term coined by the Japanese government in January 2016. Okay. So we talked about the Industry 5.0 that where our focus is on the three components: human-centric, sustainable, and resilient. So Society 5.0, this was coined by the Japanese government. What is the aim? To create a human-centered, super smart and efficient society. Again, human-centric, focusing on the general public, the super smart and efficient. Super smart means they are using all these advanced technologies, smart devices, and the efficient society. So they are improving their, the daily operations. It balances the economic growth with solution to societal challenges, aging population, low birth rates, decreased competitiveness. So with the help of these advanced technology, basically Society 5.0 means we are using this Industry 5.0 technology in a society to tackle some of the challenges like aging population, low birth rates, or decrease the competitiveness. What is the key goal? Ensure the high quality, comfortable, and vibrant lives for all citizens, provide personalized goods and services, technological integration. We integrate 5G, big data, AI in this one. So this is your Industry 5.0, this is your Society 5.0. Super smart, human-centric, and lean. What are the social barriers and limitations of Industry 5.0? So job displacement and unemployment. So automation in Industry 5.0 may displace jobs as machines take over routine tasks, dealing to unemployment for workers and unprepared to adapt. As I said, because of this advancement in the technologies, collaborative robots, automations, the workers, they may lose their job. So that's or sometimes they need to change their jobs as well. So this is one of the barriers. That's why sometimes people, they fear that this advancement or these advanced technologies are not good for the society. Why? Because we may lose our jobs. So job displacement and unemployment. Skill gaps and retaining challenges. Skill gaps, suppose the company, they are using this advanced technology, and if you are not upgrading your skills, then it will be difficult. Industry 5.0 demand new skills, but training gaps pose challenges. So the companies, they need to work towards providing these trainings so that the workers, they can upgrade their skills. Inequality and socio-economic divide. All these Industry 4.0 or 5.0 technologies, they need the huge amount of investment. So developing countries, they may struggle to take the benefits of these advanced technologies. So there will be a socio-economic disparities benefiting some regions and industries while widening the digital divide. Some countries, they may get the benefits of this one because of their economic condition, but developing countries, they may struggle. Worker privacy and surveillance. If you are tracking the workers every movement, what they are doing and what they are not doing, so this is the problem for their privacy and the other things. Reskilling and upskilling challenges for older workers. Okay, so if your workers are young generation, they can upgrade the skills. But suppose you have got the workers who are 50 years old, 60 years old, you are going and you are asking them, learn now digital way, learn now this artificial intelligence. How could they learn this? So that's another problem. Reskilling and upskilling challenges for older workers. Psychological and social impact. Reliance on automation in the workplace can impact workers' well-being, causing alienation, job insecurity, and reduced job satisfaction. Again, that's the important thing. The societal impact of these workers or this automation. Ethical consideration. Industry 5.0 raises ethical concerns, including algorithm bias, increased surveillance, and the responsible use of worker data. Ethical considerations, how do you know that the company they are using the data that they are collecting from your operations, or they are connecting from the wearable devices, how they are using for the the benefits of the company. That's the problem. Other thing, algorithm bias. We are totally depend on the algorithm. Whatever algorithm says, we follow that one. But what if suppose algorithm suggests you some wrong thing? So that's why you need to use your human intelligence. Totally blindly don't follow what the chat GPT is giving or some other algorithms are saying. Okay. And increase the surveillance. These are some of the references. And thank you. I hope you had enjoyed this session. And now Dr. Saurabh Pratap, he will take the second hour. So meanwhile, we can take 5-10 minutes break. Okay. But I am here if you want to discuss anything, not for this the session, but previous whatever 8 or 10 sessions. I am more than happy to discuss them. Okay. All the slides, recordings, everything will be shared with you. So don't worry. But in addition to that as well, suppose after 1 month or 2 months you stuck somewhere, you are working on project and you are not getting, feel free to email me. Okay. Volkswagen diesel scandal, that emission scandal. So basically, in the US, some people, when they were driving the cars, that Volkswagen Polo or some other cars, they realized that those cars are emitting huge amount of the emission. And then some people, they initially saw that problem, and then other people, they also started looking at that one. And then the government body, they started looking at those models, those were produced in the Germany or in the US plant. And after that, when they started that investigation, they found that problem. Initially the Volkswagen, it was saying that this is accidental, we didn't do anything wrong, we didn't aware of all those things. But when they again go in depth, they found that they intentionally use that tool, that device in their car, so that they can show the lower emission while testing. So as soon as your car goes onto the road, it started again emitting huge amount of pollution. No, it was installed on every car, but it gets activated when you are doing the lab testing for the emission. But as soon as you go onto the road, that device gets, it will not show you that lower emission. It will show you the huge amount of. Very, very interesting again example. You can Google it and you can find Volkswagen. They lost billions of pounds, billions of USD. They had given the compensation to the customers as well who bought those cars. Because why? Because when you buy something and you are the company is saying that this is very sustainable friendly, that's why you buy that one. But exactly, you were making huge amount of pollutions there. That's why they paid government, courts, everybody huge amount of the losses there. इधर ही खड़े रहेंगे. Good afternoon, participants. So today is the last day of our Gyan course, and in this Gyan course, our speaker, Professor Mogle and Professor Laksh. I think these two professors have taken a session, है ना? दोनों लिया था, okay. So, okay, ठीक है? हम ऐसे बोले? तो यार अच्छा ऐसे ठीक वो तो एडिट हो जाएगा ना थोड़ा सा हाँ ठीक 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 है ठीक okay. So now today is the last day. Before ending the session, there will be a two activity. First of all, the interaction session. We will discuss, we will ask the feedback, means me and Professor Mogle. And after that, there will be a short quiz. On the basis of that, we will give a certificate. And there will be a grading also. So it's a very short quiz. The marks will be 50. So you have to write in a single line answer. So I will give the question paper and the answer sheet to you. So first of all, I would like to know the feedback, how you feel, how you learned during this session. So first of all, I would like to ask, Venkat, please.
Hello. Yeah. Actually, currently we are having the course in our curriculum, but after coming here, we come to know the different aspects of it, sir. Like we are having the simulation concept in our curriculum, but after coming here, we understood how to merge this simulation and network optimization through any logistics. Not only the theoretical part, we covered the practical aspect as well. We solved a couple of case studies as well, and we have seen 2-3 sessions how to integrate these things, how to convert the optimized model to the simulation model, how to do risk evaluation and all. So it is very much interesting. It's like when we started the sessions, it was like 1-2 days, all the basic stuff. Then we entered into the advanced thing, and in the last sessions we entered into the blockchain, which is completely new. But we got the flavor of it, how we are going to implement the blockchain in supply chain, what is the essence of it, and what are the limitations of it. And I'm very much sure, like whenever we are going through the topics also, we gained some knowledge regarding how to implement it in our thesis works also in the future trends. And this is up to me. Thank you, sir. Thank you very much for this.
Thank you, Venkat. Now, Suneet, yeah, how you have feel?
Yes. Like we have got deep understanding about how these technologies like this. Okay. Yeah, myself Sunil Singh, and I'm currently doing. I'm. Is it audible? Yeah, I'm doing PhD under the guidance of Dr. Saurabh Pratap, and I have worked over maritime freight transportation, and I have also implemented technologies. But here I have got a deep understanding about technologies like blockchain, digital twin, AI, and IoT like technologies. And the session was very insightful, and we have gained the hands-on session of these technologies, like how we can implement in our supply chain, and what are those challenges and benefits of these technologies also. Yeah, it was very insightful session. Thank you, sir.
Okay, thank you, Suneet. Now, Aman, whoa, what you have learned from this course? Can you please give some insight?
Sure, sir. First of all, I thanks Dr. Saurabh Pratap sir for arranging such a insightful session for all of us, and also Dr. Mogle sir for coming here to be a guest and take this lecture and make us know about the different aspects of next gen supply chains here. Also, I thank the Ministry of Education for arranging these kind of academic network events for all of us. And actually, the session was very much connected to the base levels or the understanding for all of us or the students who can learn from the about the supply chain and all that kind of things. And actually we know about what is like digitization and digitalization is, but the basic difference or the main difference that we understood from course was very impactful for all of us. And also the difference between the uncertainty and risk and such kind of the basic things which makes us understand the ground level basics was very much good. And we learned a lot of things. The case study analysis of any logistics and all that kind of softwares was also very much learnable, and we got a lot of knowledge about that kind of softwares, and also the IoTs and all the AI technologies what we learned today also in the last lecture also was very much insightful. Thank you very much, sir, for that.
Thank you, Aman. Thank you. Now, anyone else? Do you want to say something?
The session was very informative. Right from the first day, many of the new concepts were taught to us, and we learned about the current and emerging trends of technology such as edge computing, cloud computing, artificial intelligence. And apart from knowing these terms, we were also taught the any logistics tool and its application, so that we can implement it in our future projects. That's
Thank you. Shantanu, I think you have joined late. So, what's your opinion? What's your experience during this course? Can you please?
So from the starting only, we started with the learning of software known as any logistic, and in that I learned that how a supply chain can be formulated in that software, and then I had a very little knowledge about blockchain, and with that lecture on, I then gained some experience, and the main part was that game that had we played on the blockchain, and the overall the whole session was good, and I learned a lot from this session. Thank you.
Thank you, Shantanu. Thank you. Now, I would like to ask Professor Mugle, how was his experience during this stay in IIT BHU? Can you please share some experience?
First of all, thank you so much, Dr. Saurabh Pratap, for having me here. I really enjoyed the interactions. Like on first day, I told you I like the two-way interactions, and I really enjoyed, those two-way interactions with you, and overall the hospitality and everything. It was really good. So, as I said earlier as well, if you are planning to use any of these technologies or any logistics tool for your dissertation projects or in your future jobs, and if you stuck somewhere, so you have got my email address, so please feel free to send me an email address if you have any problem, any doubts, if you are not getting. And I think Saurabh is also planning to buy that academic license of any logistics, so then you could solve some complex problems in that tool. So overall, it was very nice and good experience for me, because this is the first time I am here in IIT BHU, and I liked all the interactions, and you students are really brilliant, hardworking, sincere, because every day I had more than 20-25 students attendance. So thank you for your sincerity again for coming, because some days we had 3 hours, 4 hour sessions, and I could see your exhaustion during that time. So, but overall, thank you so much, and best wishes for your future, and thank you so much.
Thank you, Professor Mogle. Now, I have already shared the question paper. So, the question, you have to complete this by 30 minutes, and you have to answer in very short. Okay, just like a single line, very short, okay?
Don't write paragraph, only one line sentence.